Today is split group review day. Pretty much just like every Thursday. Tomorrow we got the quiz, and today we're going to go over exactly what we're beyond. Again, we have one of my good friends, Mr. Kautzal, with us again today. This is kind of the last day that he'll be with us for right now, but he comes around every once in a while throughout the rest of the year.
Oh, would you like to become a teacher?
I work with teachers, so I used to be a teacher. Now I get to support other teachers. So I just get to travel around to a lot of good schools.
Alright, so come on, go over and show us how to do this.
Maybe I will.
Okay, well, so for the first, or for the top, we're just looking at all three of these graphs. We're identifying the vertex, x-intercept, and y-intercept. On the bottom, I show you how to write each of that information. So, Diana, can you tell me, well, where is the vertex?
At the bottom.
At the bottom. So we know the vertex is that lowest point, but now we have to think about where do we start counting from? How do we know where to count from?
From the zero.
So that's perfect.
The
So again,
origin.
we always, and I love the math language that you're using, and we're starting from the zero, from the origin. So from that origin, that 0 point, and then that exact location is where those two lines cross. So where those two lines meet, that is the exact origin of our graph, that 0 point. So from there, do I need to go to the left or right to get to my vertex?
To the left.
How many spaces?
1.
So I need to go to the left one space. So for my vertex, if I'm going to the left one space, is that going to be positive or negative?
Negative.
So negative 1. That goes in that first spot. And then from there, am I going up or down?
Down.
Going down, and how many? We just have to count.
No.
And I heard Davon say it, down 9 is down, positive or negative.
Negative.
So it would be negative 9. That's all we're doing to identify that vertex. The same thing for the x-intercepts. Again, where do we start counting from?
0.
0.
Go right.
And what is the math term for that point?
Origin.
The origin. So we go to the right, how many spaces?
Well, which one we doing?
Four.
Still on that first graph, we got to do 3 different
You
pieces.
gotta go over 4.
Which direction do we go for?
Right. Left, right.
Well, which one is?
Right.
Left.
Left, right.
So the left,
Negative
4
4.
spaces. So if we're going to the left 4 spaces, is left positive or negative?
Negative.
We get negative 4. We have 2 x-intercepts. So we went to the left 4. Now we got to go to the right. How many spaces?
2.
It's kind of hard to see the lines in there.
2.
What'd you say?
It is 2 spaces. So starting at that origin again, now we're going to the right 2 spaces. Again, we're still on that first graph. Again, it's the right positive or negative.
Positive.
Positive, so we get x equals positive 2. The last piece of key information is our y-intercept. It's that y-intercept. Again, DeQuell, where am I going to start counting from?
0.
Thank you. Yam Yam. DeQuell, where am I going to start?
0.
At that 0 point. And now on the y-intercept, am I going to go up and down or left and right? Up and down, because the y is our y-axis going up and down. So here, do I need to go up or down to get to my y-intercept?
Down.
I mean down, yeah.
So to cross it, I go down, and how many? We have to count every single square.
3. Oh, yeah.
Negative.
Yep, so since we're going down, I like that you clarified that too. We're going 8
Oh,
spaces.
shit. Okay.
And it's
Make it
negative.
5.
Yeah, so you don't start at 5. And that's where we got to know, where do we start from? From that 0. Okay? So then our y-intercept is negative 8. So there, go ahead and do that for the second 2 graphs. Again, we're identifying the vertex, x-intercepts, y-intercept. Underneath that first graph, as you can see, we kind of labeled out how do we write each of those pieces of key information. Do the same thing for the second 2 graphs. I'll be popping around if you need something to write with. I got some stuff. If you have a question, just raise your hand. Awesome. I already got some people writing down that vertex for that second graph already. See people using the point of their pencil, starting at that origin in order to count what direction they're going. All right, let's take one more minute working through those, identifying the vertex, x-intercept, y-intercept. To get to where? So how do we get to here? first one. So x equals. We gotta start back over.
Here it is.
And then go to the other point. Where's the other point then? So come. Yeah. And how did we write it over here? Two parentheses. It's x equals and x equals. Make sure that we do this. How did you do this? Where did you start? Where is that starting from then? How do you know where to start now?
Right here. Oh.
So again, that 0 point will change. Start from there. Otherwise, it's up to 50.
I need help.
How do you put this point to the first?
What, over that?
Vertex is gonna be point. Very tip. That's the vertex. This is the where are your x intercepts? Where is that? East to west. So we have to know where we start from.
Squeaky chair.
So then we ask, if you go to the left, how many people go to the left? How many spaces? Start back at mine. Where do we always start? And no, you know which point to go to. It's this one. So start this way. Yeah. So always start at 0 and then come from there. Awesome. I see some people are still organizing those graphs. What we're going to do now is that point. I'm going to come over and check them in a second. The next step, that middle part, is we're looking at labeling key information now in equations and using these multiple representations and kind of prove how do we know which equation matches with which graph. Again, so we kind of have our work organized under those graphs. We're looking at different representations and going to use that to connect it with each other. So that first equation that I see there, I have f of x equals negative x squared minus 2x plus 8. I'm gonna write the first three down.
Why we ain't finished going over the graphs?
I was going over individually with everything. So if you have a question on this specific one, I can just hop around and do that, okay? The second one is, well, another way of writing f of x. What's another variable that I could use instead of f of x?
Why?
Y. So I could just write y equals x plus 3 squared
Minus 4.
minus 4. Sorry, that's number 4 underneath it, and then number 7 underneath there. Again, f of x, those just mean the same thing. Y and f of x is x plus 4 times x minus 2.
So is we labeling what they is?
Yeah, so Davion, can you tell me what is that first, what form is this in? Is it general form? What key information does general form tell us?
No parentheses.
There's no parentheses, okay, so that's how we know it's general form. And now does this tell us our x-intercepts, y-intercept, or vertex?
X. No, Y. No. X. I was just like, no.
So that's one thing that we kind of have to remember. So how do we know if it tells us our x or y
It
or
doesn't
vertex?
It doesn't say Y.
Tells us, and how did you know that, Maria?
I was just looking back.
Looking back where, at the top?
Yeah.
So looking back at the top, we can kind of look at how we write our information. The y-intercept has only one number. We know that if there's two parentheses, we kind of have both the numbers in those parentheses. So So kind of just trying to refresh our memory, knowing that general form tells us our y-intercept. Adrian, what form is this one in? Or you got it, Maria?
No, I was gonna ask you something.
Okay.
How do we know, like, if that's, I'm getting.
How do we know if that is?
That's
the
why,
y-intercept?
yeah.
So first, Adrian just said that this is our vertex form. So I'm just going to write VF for vertex form. One way that we can tell what our y-intercept is, this is when we start connecting it to those graphs. Where is the y-intercept located?
On that graph?
Yeah.
At the bottom.
Wait,
No. Which one?
In that first graph from up top. I kind of drew over here. It's kind of hard to see. So where is that located? You said it was our y-intercept was at -8, right? That is on our y-axis, it crosses at -8. So one thing that we can look at is see, well, what is our x value when it crosses? Did we go to the left or right at all
left.
No, we just went down.
to get to here?
Oh, never mind.
We didn't move. We did to get to our vertex or our x-intercepts, but for a y-intercept, we just went down. So here, what is that x value then? Well, if I was going to write the coordinate pair for it,
0,
it'd be 0, -8. So the x value is 0. So if in this form, to find our y-intercept, what does our x value need to be?
0.
0. If I plug in 0, what's 0 times 0? So that first part will go away. What's 2 times 0? 0. So that'll be taken away. What number's left over?
8.
8.
But that's not actually.
So then that's the next part. Does this first equation match with our first graph?
No.
No. Since we know that our y-intercept here is different than the y-intercept here, we know that this first equation does not match with our first graph, and we have to find which other graph up top does it match with. So it matches with one of those. We know that it doesn't match with the first one
The last one.
because the y-intercepts are different. What's the y-intercept of that third graph?
8.
Positive 8. So since this first equation has the same y-intercept of that third graph, you can just put next to that third graph, just write the number 1 and circle it, because that first equation matches that third graph. So as Adrian pointed out, this equation number 4 is vertex form. What key information does vertex form tell us?
One parentheses and vertex.
And so we know it's vertex form because it has one parentheses and it tells us our vertex. And how do we write our vertex? We kind of have this symbol notation up there. We'll write it as a coordinate pair, 2 numbers separated by a comma. So the information that's here, it tells us what our vertex is just by looking at these numbers.
You gonna pull out the 3, so it'll be a -3.
Yep, Donovan, I'm just asking you to let's pick your head up so that we can keep following along. I know you gotta see what we're doing. Let's get your head up.
It's
So
gonna
we
be
take out the first number in the parentheses, that's the one we take out.
-3.
How do you know that it's negative?
Because you gotta take it out and go from the negative.
If it's in parentheses, it'll change to -3.
And then the -4.
The -4 stays the same. Again, Maria, just like how you asked, how do we know that this works? What happens if we plug in -3 for x? What's -3 plus 3? 0 was 0 times 0. And what are we left with? -4, which is how we get our y value. So we know that if we plug this number in, this will cancel out. We get our vertex, our y value on the side. So again, here, we can now match this. Which equation above has a vertex
The
of
second graph.
-3 and -4? Looking at that second graph, we can put then the number 4 for equation 4 right next to that second graph, right on kind of the side of that second
So
graph.
we gotta do all these and write the numbers wrong.
So that's what we're doing. We're finding all the key information and then matching it to. I just did the first row of
No,
the
I'm
equation.
saying like, you said put 3, 4, something.
Yeah, so which of these has a vertex of -3 and -4? You don't see one, then that means we gotta kind of go back start counting at that origin, that 0 point, to fix those vertices. And then, Jalen, what form is this last one in? Is that vertex, general, or factor? Factor. How do we know that it's factor form? Perfect. It has 2 sets of parentheses. And what key information does factor form tell us? The x-intercept. So we'll have 2 of those. And what are they going to be?
-4 and positive 2.
It's in parentheses, it'll change. -4 and -2 changes to +2. And then again, looking at which graph
That's the first.
has the same x-intercepts, and that is the first one. Yep, so putting this number 7 next to that first graph. So doing the same thing for those other 6 equations, identifying the key information, matching it to the correct graph above.
So it's always gonna be equal to 0. Will these always 0?
And the y-intercept will always just be 1. See that here? For this
You know where your vertex is at. So what is that from? So how far over do you need? From your origin to the vertex. See what you do?
What do you mean? I'm confused.
So start at your origin.
Yes, right.
And what you do?
Or, no, 3.
Yeah.
I got a question. It is it's negative.
There is.
There's going to be positive 2.
So this number change. What's the difference?
It will be positive 2.
That's why this one's kind of tricky. This is positive 2. This one's also positive 2. So how do you know which one it is? What are the x-intercepts for that? So they have the same x-intercepts. So how do you know which one's which?
I'm telling you, this is negative 4, negative 4, positive 2, positive 2.
Negative 4, negative 4, positive 2, and positive 2. It's the same.
I don't know, look up.
So what's the difference between these 2 graphs?
They upside down.
So what about these 2?
This one will be.
Exactly. That's negative.
How you doing with the time?
Okay, so you labeled all your information right for those graphs. Now we gotta start labeling them for the equations. Okay? You see how we did it up on the board? So that's what you gotta do for these first 3 on the side. How I did it up there. So you label what form it's in, but then also the key information attached to it. So what's the key information attached to a general form?
That's the figure. I put that over here. Yeah, I was all over the place.
Okay. So then you also, you don't have to write it all out like that. You just have to tell me what it is.
That's the second graph.
So, like for this one, what
Number 2
is the
the second
y-intercept?
graph.
said what's Y intercept?
Yeah, what is the y-intercept? Uh-huh. Here, you gotta tell me what is the vertex. Okay. And then here, you have to tell me what are the x-intercepts. Okay. I'm gonna come back and check on it and see then. Well, how do you know that you got those? Okay.
I
How
need
do you-
help with number 6.
Which one was in? Okay. What information is vertex? Okay. How did you find that?
Alright, we gotta keep going with this, okay? Keep it working good, I'll make sure that you got it for tomorrow. Okay, finish up.
Okay. Can we do the last one? Because I don't never know how to do it. It look right so far?
Yep, so that last one is a word problem. This goes back to what we started a couple days ago. So kind of connecting what we've been doing all week, putting that all together. So we're looking at different forms, we're looking at this word problem and kind of picturing these graphs as we read through it. Again, it helps me to visualize things, which is why we're using multiple representations. Thinking about the graph, thinking about the shape of something as we do it, and going from there. So here, yeah, could you read that bottom word problem for us?
Why I gotta read? Why you got going on?
That's you read all
It's
right.
other kids in here, they're green.
Can you read Adrian? Thank you.
She notices that the height of the chemical can be divided by the equation y equals negative x minus 2x squared plus 9. By looking at when the ball is at its highest point in the air, Devon says that she is wrong because he noticed the clock when she threw the paper ball up and when she threw the paper ball up and when it landed. He said the equation should be y equals negative x plus 1, x minus 5. If the correct model of the equation is y equals negative x squared plus square x plus 5. Who is correct? How do you know?
Awesome. So again, we kind of had this story. Alexis is throwing a paper ball up in the air, throwing it in the garbage can. So try to picture what does that look like? Kind of the height of the ball, how does it travel? What is that flight path? She noticed, what did she notice? In order to make her equation, what was she looking at when she made it?
Factory form and vertex form.
So we have factor form and vertex form. We noticed those in there. So who made the vertex form equation?
The girl?
The girl. So the first equation that you see on there is vertex form. How'd you know that was vertex form, Adrian? Since that first equation has one parenthesis down at the bottom, we know that's vertex form. And what are the words that she uses to let us know that it's in vertex form? Again, what key information do we have in vertex form?
The highest point?
The highest point. And we can see that in that sentence, she was looking at when the ball was at its highest point. So that highest point, that's that peak, or that is the vertex, which is why she made a vertex equation. What did Devon